welcome to the deep dive. There's just this huge buzz around AI right now,
Oh,
constantly.
absolutely. It's everywhere.
But today, we're zeroing in on something specific, something that feels like a really pivotal shift, agentic AI.
Yeah, this isn't just the next version of ChatGPT or something. It feels bigger.
Exactly. We think it's a fundamental change, especially for you listening, the engineers, the technologists actually building these things. This deep dive, it's based on a whole stack of sources trying to unpack this.
Right, and we're really grappling with this central question that kept coming up. Human in the loop or AI in the loop, who is assisting whom? It sounds simple, but it gets complicated fast.
Okay, so let's get straight into it then.
Yeah.
What is agentic AI? How is it different? It's not just generative AI writing stuff, right? And it's not old school RPA following rigid rules.
No, not at all. The key difference is that agentic AI is proactive. It's goal-oriented. It actually takes actions.
Okay, actions. Like what?
Well, think about it like this. A generative AI. You ask it to write an email, it writes an email, done.
Standard stuff.
But an agentic AI, it might decide an email needs sending based on some goal you gave it. It figures out what to say, generates it, looks up the contact in your CRM, actually sends the email, and maybe even creates a follow-up task in your calendar.
Ah, okay. So it's managing the whole sequence. It's pursuing an objective.
Precisely. You're delegating the goal, not just the specific steps. That's the leap.
And the sources we looked at really highlight these core traits. Autonomy, being goal-driven, reasoning, planning, adapting.
Yeah.
It's not just following a script.
It's figuring out the script as it goes, based on the goal, which, immediately brings up huge questions about safety, trust, governance. They aren't afterthoughts anymore. They have to be baked into the architecture.
That makes sense. Which leads perfectly into our first big topic, the spectrum of autonomy. It's not binary, is it? It's not just agentic or not agentic.
Exactly right. Our sources emphasize this is a continuum. And understanding that is really key. If you're thinking about adopting this stuff, maybe in phases, you don't flip a switch to full autonomy overnight.
Right. So what does this spectrum look like, practically speaking, for engineers?
Well, at the low end, you've got reactive systems. Think basic, rule-based chatbots. Trigger, response, not really agentic.
Okay.
Then maybe assistive AI. It does analysis, offers recommendations like a sales forecasting tool. But the human looks at it, decides, and takes the action. Still no real agency there.
Got it. Then things start getting more interesting.
Yeah, next up is semi-autonomous. Here, the agent does perform tasks, makes some decisions, but only within tight parameters. And crucially, there's a human in the loop for the important stuff, approving a big purchase order the inventory agent suggests, for example.
So the human is still a gatekeeper for high-risk actions.
Definitely. Then you have autonomous execution. The system handles an entire task on its own, like placing routine orders with suppliers. But, and this is key, its actions are still strictly bound by rules we set. It operates within a predefined sandbox.
Okay. Executing but not strategizing yet.
Right. That comes next with autonomous adaptability. Now, the agent doesn't just execute, it adjusts its strategy. Think rerouting shipments automatically because of weather delays it detected. It's learning, optimizing, but still within broader human guidelines.
Getting smarter. And the top level.
That's goal-oriented autonomy. This is where the AI gets a high-level, long-term goal like improve supply chain efficiency this quarter, and it figures out the strategies, the steps, everything with minimal human input on the day-to-day decisions.
Wow. Okay, so that spectrum, it allows for a gradual rollout, right? Start with semi-autonomous, build trust, validate performance, maybe increase autonomy later.
Exactly. That human oversight early on is the safety net. It builds confidence. It lets the organization adapt. It's a much less risky way to approach it.
Which brings us right back to that core question. Human in the loop, HITL, versus AI in the loop, AI2L. The sources suggest human in the loop gets thrown around a bit too loosely.
It really does. We need more precision, especially when the stakes are high. You need to match the level of oversight to the actual risk involved.
So let's break it down. What's classic human in the loop, HITL?
HITL is when the agent must stop at critical points and wait for explicit human approval. It cannot proceed with high stakes or irreversible actions without a human saying yes.
Like approving a massive loan or maybe a critical code deployment.
Perfect examples, safety and accountability are paramount. The downside, if you use it for everything, you create massive bottlenecks.
Makes sense. So what's the alternative? I saw human on the loop, HITL mentioned.
Right. With HITL, the agent runs autonomously by default. The human is supervising, monitoring, but only steps in if needed. Maybe the system flags an anomaly or a low confidence decision.
Look, content moderation, maybe, or fraud detection. High volume, but you need eyes on the edge cases.
Exactly. Moderate risk, high volume tasks fit well here.
But then we get to the really interesting one, the one in our title. AI in the loop, AI2L. This flips the script, doesn't it?
Completely flips it. In AI2L, the human is the primary actor. The human makes the final call, exercises the judgment. The AI is the superpowered assistant.
How so?
It gathers data, performs complex analysis, generates options or recommendations, highlights risks. But the final synthesis, the critical thinking, the decision, that rests entirely with the human expert.
Okay, and why is this distinction so important, particularly for professionals?
Because in high-stakes fields, medicine, law, engineering professionals will likely resist AI that feels like it's taking over their core judgment. They need tools that augment them, not replace them. AI2L frames the AI as a collaborator.
Right. The surgeon example is great. And AI pointing out potential issues on a scan, that's helpful. That's AI in the loop of the surgeon's process.
Exactly. It's assisting the surgeon.
But an AI dictating the whole surgical plan, that feels like the human is just there to rubber stamp the AI. That's different.
Very different. So answering who's assisting whom, for these critical expert tasks, AI in the loop makes it clear. The AI serves the human expert, enhancing their capabilities.
Okay, that's a critical framing. So we're building these systems, especially aiming for that AI2L model. What does the architecture need to look like? This gets us into architectural foundations for trust, safety, and performance.
Yeah, this is where the engineering really comes in. Agentic AI needs different architectural patterns because it's, probabilistic, it's autonomous. You can't just bolt it onto existing systems.
So what's the common structure emerging?
The sources point towards a three-layer logical architecture. First, the tool layer. This is the agent's hands and feet, the APIs, the databases, the external services it interacts with. Its job is just to execute specific deterministic actions. Fetch this data, send that message.
Deterministic, okay.
Then the reasoning layer. This is the brain, usually an LLM. It takes information, processes it, decides what needs to happen next based on the goal. It does the planning.
And the third layer?
The action or orchestration layer. This is the go-between. It takes the plan from the reasoning layer, calls the correct tool in the tool layer, gets the result, and feeds it back to the reasoning layer for the next cycle. It manages the flow.
And within that, modularity seems key, right? Keeping agents focused.
Absolutely crucial. The single responsibility principle applies heavily here. Design agents with one clear purpose. Need a complex workflow. Compose multiple specialized agents. It makes development, testing, everything much more manageable.
Which leads to that single agent versus multi-agent system MAS debate.
Right. Single agent for focused tasks, maybe. But for complex, scalable systems, MAS seems to be where things are heading. Think specialized agents, a researcher, a writer, an analyst collaborating. Companies like Microsoft are betting big on this.
Now, this next point seems absolutely vital for engineers listening. The critical agent tool distinction.
It's paramount. Honestly, this might be the most important concept for building safe and reliable agentic systems. The core idea. AI, the agent, handles the judgment, the nuance, the ambiguity. Traditional code, the tools, handles the execution, the rules, the deterministic actions.
So the agent decides what the tool does how.
Exactly. The agent might decide, we need to update the customer record. It then requests that action from a specific, hardened, update customer API tool. The agent itself never gets direct database access.
So the tool layer acts as a safety boundary.
Precisely. The agent's reasoning might be flawed, it might misunderstand, it might even be manipulated by a bad prompt. But it can only act through the predefined audited tools you give it. The permissions of the tools define the absolute limits of what the agent can do. That's your main safety mechanism.
That's a really powerful concept. Okay, What about the reasoning itself? How do we make that more reliable and understandable?
Well, a very popular framework mentioned in the sources is REACT, which stands for reasoning and action.
Okay, REACT, how does that work?
The agent essentially thinks out loud. For each step, it generates a thought. Here's what I'm thinking in action. Here's the tool I'll use and the input. And then it waits for an observation, the result from the tool.
So it's a loop. Think, act, observe.
Exactly. And that loop lets it course correct if the observation isn't what it expected. But crucially for us engineers, it creates this transparent trail. You can see why the agent did what it did. It turns the LLM from a black box into more of a glass box.
Which is essential for debugging and trust, I imagine.
Absolutely. Enterprise applications pretty much demand that level of inspectability.
Alongside reasoning, context management comes up a lot. LLMs have limits.
Pretty good time. Token limits affect latency, cost. You can't just stuff the entire history of everything into the prompt each time. It's inefficient and often counterproductive.
So what are the best practices?
Using structured data like JSON or XML helps the LLM parse context, summarization techniques. Something called progressive disclosure, only giving the context needed for the immediate step. It's about providing just in time, just enough information.
People are even talking about context engineering as a discipline now, aren't they? As important as prompt engineering.
For sure. And related to that, retrieval augmented generation, RAG, is often more important, especially early on, than trying to build complex long-term memory.
Why, Ray?
Because it grounds the agent. It pulls in factual, up-to-date information from your own knowledge bases, documents, databases, before generating a response. It drastically reduces the chances of the agent just making things up, hallucinating.
Okay, grounding is key. Now, what about security? Autonomy sounds like it opens up new risks.
It absolutely does. We're talking new threat vectors beyond traditional cybersecurity. Things like memory poisoning, where the agent's internal state gets corrupted, tool misuse, reward hacking, where it finds loopholes to achieve a goal in unintended ways, even collusion between multiple agents in an MAS.
Scary stuff. So how do we defend against that?
Security can't be an add-on. It has to be intrinsic, designed in. Endogenous security, they call it.
What does that mean in practice?
Key principles. Least privilege give agents the absolute minimum tool access they need. Pre-execution policy validation, have that orchestration layer check if the requested action is even allowed before calling the tool. And crucially, avoid unconstrained autonomy. Don't let agents write and execute their own arbitrary code.
So again, it comes back to those hardened control tools as the boundary.
Yes. The toolset and the orchestration layer are your primary security controls. The agent reasons, but within a very safe, restricted sandbox defined by those tools.
Okay, architecture, safety. Let's shift to the user side, the human experience and lessons from the agentic frontier. How does interacting with these systems change things?
It's a huge shift. We're moving away from clicking buttons in a GUI towards goal delegation. The intelligence is the product, not just the interface.
Meaning the interaction becomes more collaborative.
Exactly.
It's more like talking to a teammate.
Yeah.
You state your objective, maybe clarify things, and the agent takes the initiative. The UI becomes adaptive, proactive, less about direct manipulation. But that requires a lot of trust. How do you design for that?
Transparency is everything. You have to show the work. Users need to understand why the agent is doing something. Displaying that React-style reasoning chain, but in a user-friendly way, is vital.
Makes sense. See the thought process?
And users must feel in control. Easy ways to stop or cancel. Clear confirmation steps before critical actions. That's HITL principles in the UX. Options for customization. People trust systems more when they understand how they work and feel they can override them.
The process matters as much as the outcome for trust.
Definitely. And thinking about proactive assistance and graceful error handling, AGs will inevitably mess up sometimes.
Oh, yeah.
They might misunderstand or take steps correctly but produce a weird result. The UX needs to handle these in-between failures gracefully. Not just crash, but maybe suggest alternatives, ask for clarification, or offer to escalate to a human.
So it's less about preventing all errors and more about robust error correction and recovery.
Exactly. Users need ways to diagnose what went wrong, substandard result, misaligned action, and get things back on track. It's more complex than just an undo button.
Okay, so pulling this together, what are the key lessons from the field for engineers actually building this stuff now? What are people learning?
Lesson 1, according to our sources, start simple. Solve the boring but valuable problems first. Invoice processing, compliance checks, data collation. Don't try to build a super complex multi-agent system on day 1.
Walk before you run. Okay.
2, evaluation is hard. Really hard. There's no simple unit test for did the agent achieve the goal well. It takes tons of logging, creating synthetic test cases, A/B testing, and lots of manual human review to ensure reliability. Getting from 80% right to 99% right is a massive effort.
Not trivial. What else?
3, retrieval is king, especially at the start. Good RAG, good grounding in factual data usually beats fancy memory or even model fine-tuning for performance and reducing hallucinations, certainly in the early stages.
Focus on the context. Makes sense.
4, guardrails are non-negotiable. You need clear stop conditions, limits on actions, token usage caps. Agents can get stuck in loops or do unexpected things. Default behavior should always be safe. If unsure, stop and ask.
Safety first, and the last one.
5, true, full autonomy. Mostly a myth for now. Every successful production system described involves humans at key decision points. Think collaborator, not unsupervised replacement worker. That's the realistic goal today.
Okay, so looking ahead, what's the bigger picture? Where is this heading?
The vision seems to be towards a cognitive enterprise. Imagine a mesh, a network of these specialized agents collaborating across different departments, automating complex workflows, an agentic AI mesh.
That sounds transformative. It implies human roles will shift dramatically.
Absolutely. Away from routine execution, more towards high-level strategy, creative problem solving, ethical oversight, managing the goals for these agent systems.
So wrapping up this deep dive,
Yeah.
agentic AI isn't just more automation. It's really about fundamentally redefining how humans and machines collaborate.
Exactly. And that question, who's assisting whom? It's not just philosophical. It's central to how we design these systems, how users trust them, and how businesses actually adopt them, especially the AI in the loop model for expert work.
So for you, the technologists and engineers listening, the challenge isn't just building more powerful AI models. It's about architecting systems that are trustworthy, accountable, safe, and truly collaborative. So here's the final thought to leave you with. How will you master this emerging discipline of context engineering to feed your agents that just-in-time, just-enough information? And what new frameworks, what new safety patterns will you invent to ensure the systems you build are not just effective, but inherently safe, truly enhancing human capabilities within that crucial AI in the loop paradigm?